Welcome viewers, I am Venkatesan. Today the topic is about Poisson distribution. The question is find the moment generating function of the Poisson distribution and hence find its mean and variance. Solution. First let me define probability mass function of Poisson distribution. That is P of capital X is equal to small x is e power minus lambda into lambda power x divided by x factorial, where x varies from 0, 1, 2, etc. up to infinity. Remember, in binomial distribution, we considered x values as 0, 1, 2, etc. up to, there we consider that is finite case. So, which means 0, 1, 2, etc. up to n we considered, but here we are extending up to infinity. Now, let me derive moment generating function of Poisson distribution. The formula for moment generating function is mx of t is equal to expectation of e power tx, that is summation x is equal to 0 to infinity e power tx is into p of capital X is equal to small x, which is p of x. We can substitute the p of x value here, which is already defined. So e power minus lambda into lambda power x divided by x factorial into e power tx. Now apply the summation x is equal to 0 to infinity inside. Before that, I am taking constant terms outside. I found that e power minus lambda is constant, that we can take it common. The remaining terms are summation x is equal to 0 to infinity. Here I am taking powers common, power x, here also power x. So it will be e power e power t into lambda whole power x divided by x factorial. Now you can apply x values as 0, 1, 2, 3, etc. When you apply 0, x is equal to 0, you will get e power t into lambda whole power 0 divided by 0 factorial, e power t lambda whole power 1 divided by 1 factorial, e power t lambda whole square by 2 factorial, plus etc. up to infinity. We can simplify this easily, that we already studied. We know that the expansion for e power x is 1 plus x by 1 factorial plus x square by 2 factorial plus etc. It is in the form of e power x. So this will be replaced with e power lambda into e power t. When you take lambda common, it will be rewritten as mx of t is equal to e power lambda into e power t minus 1. This is moment generating function of Poisson distribution. Now, we are going to determine mean and variance of Poisson distribution. We already know mean of, how to derive mean from moment generating function. So, we should differentiate it once and apply t is equal to 0. This is the actual way of finding mean from moment generating function. When you differentiate and apply t equal to 0, you will get lambda. The thing is, here we should use, actually here we are getting answer by using product rule. That only you should remember. Next one, how to determine e of x square. E of x square means that the second moment, again we are differentiating with respect to t at t equal to 0. Second time, when you are differentiating twice, you will be getting lambda square plus lambda here. We know variance of x formula is e of x square minus e of x whole square. That will be lambda square plus lambda minus lambda whole square. I think this term get cancelled with first one. So your variance will be lambda. Remember, in Poisson distribution, mean and variance are equal. I mean that both the answers are same, which is lambda. In the next lecture, we discuss about geometric distribution. Thank you.